was in the museum the other day looking at all these cool rock formations on display. You know, there were spiky rocks and goopy rocks, but when I made it all the way to the bottom, what I saw didn't make any sense. It was a rock, but it was like someone had created perfectly machined metallic cubes and fused them into it. Now, this was strange because this was supposed to be a natural formations display, and these cubes were obviously human-made. Am I the only one who thinks that? Like, am I dumb? Well, but turns out it wasn't fake. So naturally, my next question was, what sorcery is this? Impossibly perfect-shaped rocks. The cubes are called pyrite, and despite looking like a metal, it's actually a crystal. And in a specific mine in Spain, you can literally pull these perfect shiny cubes right out of the cave wall. Okay, but how did these form in the first place? Well, if you zoom in, you'll see that pyrite is made of the elements iron and sulfur. Initially, they float around as ions in hot water underground, and as the fluid cools, opposite charges attract and they begin to crystallize. When forming crystals, atoms like to arrange themselves in a lattice, which is a repeating arrangement that keeps the crystal stable. The simplest repeating pattern in a lattice is called the unit cell, and it just so happens that the unit cell for pyrite is a perfect cube. But it looks really complicated like this, so let's just stuff it all into a box and think of it as a cube-shaped Lego brick. In the right environmental conditions, these Lego bricks build up evenly, layer by layer, resulting in a fake-looking cube. And sometimes you can even get multiple pyrite cubes growing in each other, leading to all sorts of cool designs. But a cubic unit cell doesn't necessarily mean you'll get a cubic crystal, like in the case of garnet, where different environmental conditions make it form perfect dodecahedrons instead. And cubic crystals aren't even rare in nature, like if you look really closely, table salt is cubic. Anyways, I'm convinced that you're real now. Wait a minute. If this crazy looking rock was right under my nose the whole time, what else are you hiding under there? Musical rocks. In some special areas of the world, there are fields of rocks that can sing. They're called ringing rocks, and when you strike them with a hammer, they ring out like a bell. Using these, ancient civilizations would make an instrument called a lithophone, which is basically a rock xylophone. But there's some debate about why these rocks actually ring. One informal study from the 1960s cut up both a ringing rock and a normie rock, and after measuring the initial dimensions, they waited a bit and then measured them again. The normie rock, well, stayed normie. There was no change in size, but the ringing rock actually expanded a little, indicating that there were some internal stresses that were released after the rock was cut. And the theory is that these internal stresses are what causes the rocks to ring. It's also been found that rocks with higher internal stresses ring at higher frequencies. So maybe if you want a higher note, you need to stress out the rock more. But unfortunately, people kinda suck, and most of the smaller ringing rocks from these rare areas have been stolen. And it gets even worse. There's only boulder-sized ringing rocks left. But this hasn't stopped people from taking chunks of them home as souvenirs. The annoying part is, breaking these rocks releases the stresses inside them, meaning they lose their musical ability permanently. You gotta take care of the earth, people. Like, treat it nicely. What? Glowing rocks. Under visible light, some rocks appear normal, but under ultraviolet light, they glow. How cool is that? Glowing rocks have special atoms in them called activators, and when UV light shines on one, the energy excites an electron, causing it to jump to a higher energy level temporarily. But after a fraction of a second, the electron loses its energy and falls back down to its original energy level. As it does, it releases the extra energy as a photon of visible light. And because there's millions and billions of these activator atoms all releasing photons at the exact same time, your eyeball perceives this as a glowing rock. This property is called fluorescence, and I have a really hard time spelling the last half of that word. The color of the glow depends on the chemical element of the activator atom. For example, manganese activators cause red glows like in calcite, uranium activators cause green glows like in autunite, and molybdenum activators cause blue glows like in scheelite. But fluorescent rocks lose their glow when the UV light is turned off. But there are some rocks that keep glowing without it. The property is called phosphorescence, and it works in a similar way to fluorescence, but instead of the excited electron falling back down quickly, it gets stuck at the higher level. This is due to something called a forbidden transition, which sounds quite ominous, but basically due to quantum rules, the electron holds on to that extra energy longer and releases it slowly over time. So you get a sustained, continual glow until the electron eventually drops down to its original energy level. This is what's used in glow-in-the-dark stickers, and it also explains why they eventually died over time. But did you know that you could recharge them if you use a blacklight torch? And it doesn't stop here. Glowing rocks speed round. Thermoluminescence causes rocks to glow when you heat them up. Although most objects will eventually glow if you heat them up enough. Triboluminescence causes rocks to produce light when they're scratched or crushed, like sugar cubes, which produce a small flash of blue light when you smash them. Electroluminescence causes rocks to glow when you electrocute them. And radioluminescence causes rocks to glow when they're bombarded by radioactive decay. So rocks can form perfect cool shapes, they can sing, they can glow. What else can they do? Magnetic rocks. I like to put myself in the shoes of early humans coming across crazy phenomena in the world. Like, what would it be like to see lightning for the first time? Or discover fire? Or find out that these mystical rocks want to do this? Witchcraft. There are stories of ancient people thinking that magnetic rocks had some sort of life force or soul, which allowed them to attract other objects. We now know it's a type of iron ore called magnetite. Usually it's just attracted to other magnets and doesn't do any of the attracting by itself. In very rare cases though, the ore is permanently magnetized and doing the attracting. Okay, so how did this random rock become a magnet naturally? Well, for a magnet to be magnetized, it needs to be exposed to a strong magnetic field. And the Earth has a magnetic field, but it's way too weak to create a strong magnet. So instead, the theory is when magnetite is just chilling, minding its own business, it gets struck by lightning. The strong magnetic field of the lightning strike permanently magnetized the iron ore, creating something called a lodestone. This also explains why lodestones are quite rare and only occur near the surface. This lightning theory was also supported by a NASA dude's experiments, where he shocked some magnetite in a lab and artificially created a lodestone. At this point, I'm like, what can't rocks do? Like, next you're gonna tell me that some rocks are alive or something. Why have you gone silent? Living rocks. Maybe. Around a small town in Romania called Castesti are a bunch of lumpy-looking rocks called trovants. They might look innocent and unassuming, but if you've lived in this town for long enough, you'd know that there's something fishy about them. They come in all different shapes and sizes. Some are tiny, some weigh several tons, and some are super duper lumpy. In Romanian, the word trovant translates to growing stone, and they've been recorded to increase in size, especially after it rains. And their strange behavior has become a part of local myths, with them being thought of as dragon eggs. But when scientists cut one sample open, they didn't discover a dragon, but actually a bunch of ring layers instead, sort of like the growth rings of a tree. The theory is that because trovants are porous, meaning they have a lot of tiny holes inside them, they're able to absorb minerals from the rain. Over time, these minerals build up inside, creating outward pressure forcing the rock to expand. This process is very, very slow, and the rocks are estimated to grow a whopping 4 centimeters every 1,000 years. So basically, every time it rains, it's sort of like the trovant's feeding time. But it doesn't end there. Sometimes the trovants grow a bulb, and with enough time, it can break off from the parent rock, creating a mini baby trovant. And then the baby trovant can grow too. So if you want a pet rock, a trovant is your best pick. Wait. Actually, no. Leave them in Romania. Back! No touching! I didn't really know much about rocks before this, but I had a lot of fun learning about these little goobers. If you did too, maybe like and subscribe. Also, look at these goobers. They're great. Anyways, see ya next time.